All right. Hello, everyone. Hello, everyone, and welcome to the first Springboard webinar of the year. Yeah, welcome everyone to the first Springboard webinar of the year. Can I get some reactions? We're super excited to have everyone join us today. From our registrations, I know that we have students from different parts of the world, basically. We have people from Nigeria, of course, from the United States of America, different schools. We have students from South Africa, from Ghana. You're welcome from any location that you're joining us here this afternoon. We are so excited to have you join us today. My name is Rachel. Absolutely. I can see someone from Ghana. You're welcome. If I mention your country, you can just drop something in the chat box. Yeah, so we're super excited. My name is Rachel, and I'll be your host for today. Um, Today's topic is research and enterprise. And the session is going to be our speaker is going to be speaking for like 30 minutes, after which we're going to have a question and answer. He's going to be answering every question you have today. And the topic we have is very insightful and very, very important. And personally, it's my utmost pleasure to introduce to us our speaker for today. He was introduced to me by Ernest a couple of weeks ago, and he was more than willing to come here today to share his expertise and time with us. So thank you very much, Jared, for being here today. And on behalf of Springboard State College, I want to say thank you to everyone that has taken their time to be here with us today. We really, really appreciate it. Quickly, I just want to talk a bit about Jared. So Jared Yarnall Schane. I don't want to murder the name, but yeah, I think I got that part down. Yes, Jared is currently the Alliance Officer within Penn State Tech Transfer Office, where he works to build partnerships that bring research out of the lab and into the industry. Prior to joining Penn State, he served as the Director of Innovation at the Biomimicry Institute, where he supported nature-inspired scientists and startups in bringing their ideas to life. I don't want to take too much of our time. I'm just gonna hand over to Jared. And as the session goes on, guys, just drop your questions in the chat box if you have any questions, so that they're addressed afterwards. So I'm handing over to Jared now. You're welcome, Jared.
Great. Thank you so much for having me, Rachel. And it's so nice to be here. Thank you everyone for spending some time with me today. Um, so yeah, before I dive into the presentation, I thought I would just help expand upon that introduction a little bit. So I'm currently in the Penn State Office of Technology Transfer, and in our office, we work to bring research invented and discovered and developed at Penn State out of the lab and into industry. And before that, I have worked with about, I don't know, over 60 startups, um, specifically in the climate tech and ag tech space, as they are working to launch new ventures that are solving some of our big issues in food security and climate change. Um, it's been great to work with founders from around the world. I've worked with founders and in some of the countries you mentioned on the call, and from Ghana and Uganda, as well as Brazil and Indonesia, the US, the UK. So yeah, it's really great to be here, and I'm excited to share some of the things I've learned. So please do put questions in the chat as time goes along. Yes, Rachel.
Yes, yeah. Sorry, just to mention, I forgot to tell as many of us that can turn on our camera. You're muted. You're still going to be muted, but would appreciate seeing other faces besides our speaker's face. We really appreciate that. Thank you.
Cool. Thank you. So yeah, please do put in questions as this goes on. I'll have a presentation. I don't know if it will take all 30 minutes, but we can stop and kind of have some dialogue back and forth in between, and then we'll have some time for some specific questions afterwards. And I do want to say what I'll be sharing will come a little bit from the Penn State perspective and policies. If you're at different universities, things might be a little different, but hopefully this paints the picture for what a large research institution does and would be looking for. So with that, I will share my screen. Great. Okay, excellent. So during today's talk, I'm going to talk a little bit about what translational research and research commercialization is. I'll share some examples here. I actually have some videos that I'll be sharing to help paint the picture for why this matters. Then I'll talk a little bit about some of the pathways that exist to amplify and bring research out of the lab. And then finally, I'll briefly touch on universities and intellectual property and how we can be a support kind of system to move things forward. So yeah, at a very high level, research happens at universities all around the world. At my home institution, Penn State does about $1.4 billion worth of research every year, which is a whole lot of money and a whole lot of research endeavors. And out of that, the scientists and faculty and grad students often come up with new inventions, new discoveries that could be turned into a product. Um, there are many different ways to get things out, which we'll talk about, but in short, once those discoveries are made, they can come to our office. We figure out pathways to protect them and then to get them out into industry and then eventually get them sold on market. And the goal is one, we generate a little bit of money. This is really not a commercial revenue generating operation. Really, our goal is to amplify the amount of impact that research can make in the world by bringing new products and new things to market. So with that, I'm going to share my first example. So here is a video. Let me know if this works once I hit play here.
This carnivorous pitcher plant has a particularly gruesome party trick, a highly slippery outer rim which causes insects to slip into a tube full of digestive juices. This super slippery rim, called a peristome, consists of a micro-textured surface which becomes incredibly slippery when it gets wet. This microtexture is formed from overlapping epidermal cells, which cleverly directs insects to slip inwards and not out of the plant. Now, a company called Spotless Materials is designing its own coatings that mimic the slippery nature of the pitcher plant. This coating features tiny nano hairs, and these hold a thin layer of lubricant which mimics the presence of water on the pitcher plant. The company calls this technology the Liquid Entrenched Smooth Surface, or LESS for short, and it can easily be sprayed onto a variety of surfaces. Because less coatings make surfaces very slippery, it allows them to stay cleaner for longer, as they naturally repel fluid, dirt, bacteria, and even solid waste. This is particularly useful for things like solar panels and camera sensors, but also for reducing the harmful effects of using toxic cleaning products. It's even been used to create super slippery toilets, which repel human waste and save vast amounts of water. Thanks to the pitcher plant-inspired technology, these coatings have the potential to save billions of dollars in cleaning costs for all sorts of surfaces, which is great news for the planet, unless you're an ant.
So that's a fun example of a technology I actually got to work with when I was at the Biomimicry Institute and worked with the founders, and it actually originated from Penn State research. And I think that's a tremendous example of showing a observed phenomenon, so something that's observed in nature, and then figuring out how that observation can address a need. So this is something I often like to bring up when I give talks, is there's often different ways that things can be developed and brought out of a university. On one hand, there's things that are, wow, what an amazing discovery. I wonder what this can be used for. And we call that a technology in search of a problem sometimes. Other times there's a problem in search of a technology. Maybe there is some sort of we need XYZ type of material to solve this big industry problem. How can we then develop the technology to do so? So both paths are correct. Both paths work. I just like to share that as I think they're two distinct different ways to go about creating a new innovation, and it often will change how we think about getting things out of the lab and into market. So just to show a little fun rendering, this is a glob of oatmeal that they made, and a toilet coated with the spotless materials spray. So this product is on market both for consumer households, but also they have a lot of industry partnerships as well to bring super slippery surfaces to industry. Um, I think this is a great example of how an innovation ecosystem can work. This started with fundamental research funded by, I believe, the NSF and some other federal agencies in the US. But this also received Gates Foundation funding as part of the Reinvent the Toilet Challenge to create waterless toilets that can be used around the world. The PhD student, my friend Birgit, actually launched this company. So as a PhD founder, she went through several university programs and then ultimately made the step to launch and run the company. And I think that this is a really interesting one to think about. I call this a platform technology. So super slippery surfaces can be used in a wide variety of things, as that video mentioned. And often what we see is university research are platform technologies that can be used uh, for many different applications, which sometimes means it's hard to develop and hard to raise money for. But if you can do that and you can do that well, there's really a lot of room for impact. So now I'm going to go to another example, and this one is going to be a little bit different. Um, but this is also another example of translational research impact. So this video was actually made for a recent event we hosted at Penn State. We actually just had the event last week. So this is kind of in the context of our award winner Brett talking about the solution, but I think this does a really good job of showing a different type of translational research that can come out of a university.
When you think about innovation, typically we think about material science or something that's tangible, but it's really identifying a solution to a need or a problem, and that can come from anywhere. My name is Brett Schofield, and I'm the Executive Director for the Center for Collegiate Mental Health at Penn State University. Over the past 2 decades, the landscape of college student mental health has significantly shifted. Students are more comfortable asking for care now than they ever have been, and that's been positive. But the consequence of that is that we've been unable to keep up with the demand for services. And we knew that industry was going to play a role in helping support students. But the problem was there was no standardized data to help inform care. When we developed the Center for Collegiate Mental Health, it was a way to provide a scientific foundation to understand what was happening with college student mental health nationally. One of the tools that we use is the Counseling Center Assessment of Psychological Symptoms, otherwise known as the CCAPS. The CCAPS has given us a way to partner with vendor companies to help those vendors improve the care they provide to the college students. We recently engaged in an agreement with Better Mind, which is a leader in telehealth in the college student population.
It's been a real pleasure for us to work with the Center for Collegiate Mental Health. I had no idea private licensing of the CCAPS was an option, so it was really exciting for us to learn that this was on the table, and Brett played a pivotal role in making this come to fruition for us.
This company has over 150 schools that they work with. So our tools are now going to be impacting many more students than they were before.
I'm really appreciative of Brett and the ingenuity of licensing the CCAPS. It's been a really exciting part of our development as a company.
By us licensing the CCAPs to an industry leader, it allows us to drive the industry standard for data-driven care in the field. I would like to
So I love to show this. I chose to show this video because it talks kind of about a different type of innovation, and this goes from that other side where there was a problem, a solution was created for that problem, and now we're able to take that solution and amplify it out even further. We're really proud of this. This is just a recent thing that Penn State was able to accomplish in getting this out the door. But I think it also goes to show how, like Brett mentioned, innovations are not always new products, they're not always new materials. Sometimes they're surveys. Sometimes they're large data sets. Um, and the goal here is not that it doesn't just live in an academic kind of environment as an academic exercise, but it really gets out there and makes a meaningful impact on people's lives. Um, so I think some key things I already mentioned. This was kind of a solution solving a problem that we were able to amplify. This did take decades to develop, and Penn State is well known in this type of work as a leader in the field. And it's because of those decades of work. So if you are thinking about how this might apply in your own work, I would encourage you to think about that is what might exist at your institution or within your research that you have been developing, that you have established some key expertise on that might be able to be amplified. And then I just did a little bit of searching right a little earlier today around the scale of the problem. So, this was developed at Penn State. This is now a tool that will be used by hundreds of different universities. And I think most impressive in terms of impact is that 60% of college students have at least one mental health problem, which is a scary statistic. But I think that just goes to show the breadth of reach that something like this can make on the world. So I'm going to transition now into kind of the next phase of the talk, but maybe I'll pause here to see if there are any questions that anyone has about those two examples I shared or anything that you want to kind of ask about there. That's okay. If any come up, please go ahead and put them in the chat. I'll be happy to answer them as I go along. So, um, now I was jotting down some of the different kind of pathways that one can amplify research, because that's really what we're talking about here. And um, we'll start with some of the ones that scientists often think about. It's academic publications. How can I get this in a peer-reviewed publication and get this out there and help my peers see what we're doing and move the body of science along. And that's really what fundamental science is, and we're going to always continue to do that. We should continue to do that. But I think we're at a time, especially here in the US, um, where research is being questioned. The importance of research is being questioned, I should say. And this kind of translational research is really important to show the societal benefit that it has um, on society. So there are different pathways. These are not all of them, but I just wanted to jot down a few of them that exist to then start think about how we can start to expand that impact. So a lot of times researchers and labs will begin to open source um, their work. This is especially true if you are kind of creating a digital product. You might open source code, or there might be open source data sets. Um, which is great. I think one thing that you might miss with open source, I actually launched a product that I tried to open source. It didn't go well, but one thing I learned was, one thing you might lose is control of that data or product. So um, if you do open source something, I'd really encourage you to think about what unintended impacts might happen if a bad actor kind of comes in and takes this and uses it for their own purposes that don't align with your morals and your mission. Um, at universities, then there's often a lot of sponsored research that happens. That's another way where industry can come in and pay directly to access kind of new research. Um, I always like to see that paired with licensing. So our office primarily handles licensing agreements. So that simply means that we'll, if some new type of intellectual property is created in Penn State, we will often file a patent to try to get patent protection on that. There are also other ways to protect things like copyright or trademark or trade secrets. Um, but once we have some sort of protection in place, we can then license that as a tangible asset out to another company. And what we are seeing works really well is when we do a licensing and sponsored research joint development agreement to continue development of products. So a good example for that would be something called Lion Glass. I can share, maybe I'll actually just pull up the website now. This is a great example of some joint development work that's ongoing at Penn State. It's a new type of glass that uses more than, or sorry, it emits more 50% less carbon than traditional glass, and it's also a lot stronger than traditional glass. So we're quite excited about this, but it as a new type of material, it needs a lot of work. Yeah, that's great. It needs a lot of work to get ready for industry. So there's some good stories here. This is another great example. I'd encourage you to check out this website. And then the one that I have spent most of my career on and that I'm incredibly passionate about is launching a new startup based out of technology and research that you develop. Um, Often, if something's developed at a research university, the best person to spin it out would be a grad student or postdoc in that lab, because often technologies, actually what is most needed at the early stage is for the technology to be further advanced, to get ready to enter market, and the grad student and postdoc are best equipped to do so. So yeah, I think these are all things to consider as you think about translating your research out of the lab. There are policies so Penn State has a lot of policies. Or big organizations, so there's a lot of rules you have to follow, but hopefully we make them clear so that you can follow them. I think some things to consider are what's expected in your industry. So the Lion Glass example I gave, it would be very unlikely or uncommon for a new startup to emerge in the glass production space. This is a pretty almost an ancient a skill, an art form. There's a lot of artisanal, small glass makers, but the major kind of glass companies, um, the investment needed to build a new manufacturing facility might be in the hundreds of millions of dollars. So it makes more sense to license directly to industry than to try to create a new startup company that would need require all of those resources. Ooh, okay. And there's a great question that came in the chat, and this is a great time to answer that. So the question is how can researchers balance the requirement of government-funded projects with the need to translate those results into commercially viable products? I'm going to jump ahead to a slide here because in the US, this has actually been answered. So um, in the 80s, I'm not an expert on this legal construct, but I will try to do my best to explain it, and then I would advise everyone to just look it up. But um, in the 80s, there was a bipartisan coalition called the Ba-Dole Coalition that created a new law that actually universities with publicly funded research are required to try to protect and patent any novel inventions coming out of that research, and then are required to try to bring that to market. Um, so our office, we will never keep you from publishing. We will work around your publishing schedule. We believe that is, as a faculty member, that is your key kind of thing. We want to support that and we will support that. What we will do is when you are in the process of discovering something or maybe in the process of developing your paper, we ask for something called an invention disclosure. I'll go back a slide here. Um, we ask for people to submit an invention disclosure. That essentially kicks off the process of working with our office, where then we have specialists in physical sciences and life sciences and IT who then get assigned to you to evaluate if this is a novel invention or novel discovery. We then work with legal counsel to file a patent on that technology if it needs a patent, or to go through whatever other sort of intellectual property creation is there. And then all of this is done via Penn State resources and Penn State money. And our office manages this whole thing. And then through this process, our team is also responsible for trying to market this out there to industry or to work to license it to a new startup. All along the way, um, we work, like I said, around kind of the faculty. Like this is we want you to publish academic papers on this, and we always make any new invention accessible to researchers. So researchers have the right to continue to develop and iterate upon this. Um, we just have stipulations in place for for-profit industry coming in who want to maybe profit off of the work that was developed at Penn State. But yeah, it's a very good question. I don't think I did the best job of answering it, but I did want to just kind of reiterate that we're actually legally required to try to go through this process. And this is one of the things that the current White House administration is going after some of the large universities, including Harvard, for they're claiming that they are out of Basel compliance. And there's a whole lot of issues. You could just Google search that and you'll see some of the articles about that. But um, yeah, it's a good question. Our office is very aware of this, and we have a whole team of compliance people to make sure we stay in compliance there. Yeah, it's a great question. Um, so yeah, I already kind of touched on this. That was a great question. You jumped right into where I was going to go. But essentially, we get invention disclosures, we analyze how to protect it, then we figure out how to license it. We also have a funding mechanism at Penn State. So we have something called the GAP Fund. Let me pull the website here. So this program provides $75,000 to the PI and research group to continue to get your technology closer to commercialization. One thing we ask for here is that there's some industry feedback that we can use kind of as a metric. So I'll use Lion Glass as an example. When we first started to approach industry, they raised a concern um, that they were concerned about how this might impact glass recycling streams. So we knew that that was a big issue in the possible licensing of getting Lion Glass out there into the world. So we were able to give them one of our $75,000 grants to try to de-risk that, to come up with an answer to that question. And we have now been able to secure multiple licenses to bring Lion Glass out of the lab. But um, I wanted to throw that out there. It's a unique program we run, and I think it's a really good thing for our university. And hopefully we see some of your applications come in if you're at Penn State. So, all right, I'm going to move ahead. So, yeah, I talked a little bit about the intellectual property, about the Basel compliance. Um, I'm not going to get too much more into that. That's not the work I do. I really focus on the resources and connections and then figuring out how we increase our impact. We have many, many, many companies in our network. Penn State works with a lot of companies. However, we find most success comes from introductions made by the researchers. Often, research scientists or maybe your PI, or if you are a PI, your grad students have gone on to industry, and they might be the most interested in what you're developing. So we often find that a lot of our job is to upskill the faculty to figure out how to help position this for their industry contacts to continue development. And I will say that Penn State historically, this has not been a strength of our university. It's something that we are working on, and I think as we see more success stories, we're just going to kind of it will be easier and easier for us. And then I have to mention the financial reward. So, um, if you invent something that is wildly successful and it's licensed to industry and it's starting to generate a lot of revenue, um, the financial incentives are set up as the following. So, 40% of the revenue that gets tied to royalties. So let's say we license something out and we have a condition that we get 3% royalties on all revenue generated by XYZ product. Of those royalties, 40% goes to the inventors. So if a product generates $10 million in royalties, $4 million would go to the inventors. 40% goes to the Penn State Research Foundation so we can continue this work. And then 20% goes to the home college that product was invented at. Um, so there's financial incentive here as well if the impact isn't enough. Um, and then I'll just end with this because I saw a question as I was preparing for this talk about resources. So if you are a grad student, the number one resource I'd recommend that you pursue, and if you're interested in translating your work, is to participate in the NSF I-Corps program. Let me drop a link in the chat here. But this is a program that helps uh, either faculty or grad students meet with 20 to 30 industries representatives to kind of stress test your idea. The goal is that you might think it's a brilliant idea, but if industry says, "Yeah, no, that's not interesting," well, maybe you need to pivot, or maybe you need to find out another path forward. Um, there's a regional program that is actually accepting applications now. And then there's a national program that comes with a $50,000 stipend to help advance this work. And if you complete both the regional and national programs, there's a lot of other opportunities that are available for grad students to secure capital to launch a new company based on their research. So I think this would be my one of my go-to that I would suggest for any of you here. So um, So that was it for my talk. I hope I answered some of the questions that came in beforehand. I hope I shed some light on kind of the research to impact ecosystem. Um, I'm more than happy to answer questions, to share more examples. Yeah, please send them my way.
Right.
Thank you. Thank you, Jared. Thank you for that precise and insightful session. I'm gonna hand over to Debo now. Is going to be like asking questions that yeah, some people have asked before and new questions, of course.
Great.
Thank you so much. Can you hear me?
Yes.
Okay, yeah. Great presentation. Yeah, so we kind of received a couple of questions prior to, we've put this out before and people have been like interested in this couple of questions. And I'm going to be bringing those questions up one after the other, and then we can raise them. Um, I, all right. So one of the question is, I'll start with this. We many times researchers, they have a lot of skills, they are mostly in the lab, they know how to do their thing hands-on. Well, do you think there are more skills that beyond research that needs to be like developed or built to successfully translate this research into markets? What do you think?
Yeah, oh, it's a great question. I think if you can be a researcher, you can figure out the business side of things. I have a lot of confidence in that. I also think that one of the best things that you can learn is to be okay with what you don't know, and then to know how to either ask for help or to find the right people who can help you on your way. So, I actually have seen most of the success stories I've worked with are the researchers who have turned into CEOs and entrepreneurs. Because often you're developing something that is highly technical and it really needs someone at those early stages to continue to develop that technology. However, the thing that makes these individuals stand out is that they're coachable. They receive feedback and they act upon that feedback well. Um, they're very good at networking. I think that is a key thing here. You have to be good at networking. If you're trying to raise outside capital, I've heard it that it takes between 60 to 100 meetings to get the first person to say, "Oh, I might be interested." So you have to be resilient as well. You have to be able to take no and not let that stop you. Um, I also think though that there will come a point where it might be time for you to take a step back and to let someone with more of that kind of business experience in. Um, and hopefully by that point you have a lot of advisors around you who can help advise on how to make that transition work well. So I hope that helped answer that question.
Yep. Awesome. Thank you so much. Um, Also we have another question here. Um, I think this also like touched on the networking thing. The question goes thus, what are the best practice for collaborating with technical experts to develop this research idea into tangible output of prototype, which can also which can also while also protecting intellectual contributions. Yeah.
Yeah,
So I guess.
this is honest. I think there's going to be a lot of different answers to this question. I think I think in some ways that this is domain kind of specific. So, for example, next week I'm hosting the company Catalent to visit Penn State. Catalent is a contract drug manufacturer, and it's called a CDMO, is the initials for that. But essentially, there's a whole ecosystem set up in the drug development space that that it just frankly wouldn't make sense for any one of us to learn and become experts in. Like we just have to find the right experts and then work with them and figure out what materials they need to take it to the next level. Um, so it is hard to answer. I think unfortunately a lot of times collaboration is also a monetary exchange. So sometimes you need to have money in order to do a successful collaboration. Um, if it is truly like a mutual collaboration of interest, um, I think what works best and what we see best is when there's multidisciplinary people at the table. It's one thing I love about Penn State is we have material scientists working next to biologists, but I do see that the best results come from for that multidisciplinary kind of transdisciplinary collaboration. The spotless materials video I showed is a great example. It's a mechanical engineer studying biology, and now they're creating nano materials. Right? I think it's just a really cool story. So.
Yep. Awesome. Thank you. So, because many of the people on this call are class students, and this question will probably help them to, know when to kickstart things. And the question is, at what point exactly should someone in the lab start thinking about commercialization? You know, based on the numerous um patent from the office, the numerous people that have come to office to like, oh, we think this could be patentable and we want to translate this to commercial stuff. When should a student start thinking about commercialization?
Oh man. So I am not a researcher, so I might have an answer that does not resonate with everyone.
Okay.
But I think that honestly, when you're starting to develop a new project,
Mhm.
you should begin to think about the commercial applications. That doesn't mean that it is going to be a commercial application, but I think it will help it will help make the proposal and research project stronger. And I'll give a very specific example. Um, I was helping to advise a researcher a few months ago around a proposal for kind of a small amount of funding. He had this idea to make a new type of fertilizer using microbes. Um, on the surface, it sounded great, but something just felt off. Like it was like, okay, why has this not been done before? So we were able to call up an advisor who had farming experience and who has sold products to farmers. And within 30 seconds, he was able to say, this is a great idea. The main thing you have to consider is that farmers spend, I don't know, $50,000 to buy a fertilizer spreader. And how you are describing this product won't work in the fertilizer spreader. It will get stuck. So all of a sudden, he had some brilliant insight from a kind of commercial entity to say, oh, okay, this might be of interest, but in order for this to work, this would have to be a key consideration of experiments and of kind of the development going forward. So I think there's other ways that you could look at this in terms of like policy as well. So like uh, there's let's say you're trying to develop I'm just going to revert back to another agricultural solution. Let's say you're trying to identify a solution to a pest problem, and you're trying to create a new pesticide or crop protection method. If you're developing something that would be impossible to go through FDA or EPA clearance, then it has very little likelihood of getting out into market, because right, there's pretty defined metrics that you have to hit to go through the regulatory process. So yeah, that's my answer. I think other people would answer
Yeah,
differently, but
yeah,
I've seen success in that way. Yeah.
yeah. Thank you so much. I'm just kind of building on that. Most of the time you think this thing makes sense, and then when they start like testing and training that kind of idea, you figure that maybe there is need to do more stuff. Maybe there is need to consider exercising. This question kind of like you know puts that into another possibility. So, uh, sorry. So, what common mistake do you think people often make when they are trying to translate their work into impacts? Like, if you had, if if you have to answer this with one sentence, like the most common mistake that people make, when they are trying to like translate these ideas into.
Good question. Um, I have two. So
Okay, yeah, you
I
can.
I think I think the first one is listening to the wrong type of validation. So in my old work, we used to call it the mom test. And the theory was you could tell something to your mom and she might just say, "Oh yeah, that's great," but not actually give you the real kind of hard feedback that you might need to hear. And the premise being is it's actually better to learn from past behaviors than it is to pitch and say, I could pitch anyone here on this call right now a new idea. You might be like just out of social norm and etiquette, you might not tell me that's a bad idea. It would be better for me to study your past behaviors to determine if it is something that you would consider. So that's one. I think the second one, um, yeah, actually, I'm just going to go with that. I think that's the big one. Oh, the second one is people are too protective of their ideas. Especially I think scientists sometimes, like, you've spent your whole life working on something, you think if you say it to the wrong person, someone can just take it and run with it and steal your baby. That's never going to happen. It really it comes down to execution in this space. It comes down to who can execute upon this the best. And I think we should be less worried about that. So, and I saw a good question come in the chat here.
Yep.
In light of IP policies that assign ownership to the institution, what strategies or mechanisms can grad students use to secure recognition, shared ownership, or future rights? Good question. Um, I'm going to answer the best I can, but I would encourage more research about this as well. Um, so, and I can only speak from the Penn State perspective. So, at Penn State, when we receive an invention disclosure, we are one of the questions we ask are for all parties who contributed to the invention. Sometimes that's one person, sometimes that's 15 people. Part of my team's job is to then understand um, kind of the levels of contribution, and those levels of contribution will determine a couple things. One, that will determine if you are an inventor on the patent, if we file a patent. That's a whole kind of subset of in the legal space that I don't feel comfortable going into, but um, that can get messy sometimes because often I believe inventorship goes to the people who created the idea. And if you are following like directions, sometimes that doesn't qualify as being an inventor on a patent. However, on the other side, we also are looking to see if this is a wildly successful commercial solution. Um, who on this inventing team of the 15 people that got disclosed should receive royalties and revenue from that work. Um, I will say often what we see is it's a PI and a grad student. Usually there's one, like two people. Usually it's a PI and a grad student or postdoc who are the key contributors, and then there's usually a supporting cast around them that also receives some of that recognition. Um, I'll also say Penn State, based on what I've seen other universities, were very friendly with working with people who want to turn their research into startups. So if that's of all at all of interest, we kind of go out of our way to make sure that we can do that with you. Other schools, sometimes it's not as friendly. So, yeah. Good question.
Thank you so much. Yeah, so someone asks, how can you measure a risk, like the impact of a research when it is like a long-term thing? How
Yeah.
long can you stay with such a person to like really push that idea? How long?
Yeah, I think well, I mean, there's whole fields of research. Penn State actually has a center that's, I think, fairly well known called the Evidence to Impact Research Center, where they're trying to answer that very question. I'll drop it in the chat here. Um, I do think that it's important to quantify for both research purposes as well as possible like translational purposes. Like, um, if you can say you were an inventor on a solution that helped 500,000 college students with mental health issues. Like that's a pretty powerful thing that will probably get you more grant funding and will probably open a lot of doors into the future, as well as uh, probably help with some of the translational research work. But I don't really have a good answer. I think it will be dependent, but based upon my kind of personal experience, tracking, understanding what impact measures you need to measure for, and then figuring out pathways to track them is incredibly important and should be considered kind of right up from the beginning.
No, c'est
Thank you
mon
so
time.
much.
Attends,
Just sorry for the background noise. Can we
Yo,
mute?
mon check-in budget.
Sorry. Can we mute engineer for this? Yeah, thank you. Yeah, sorry about that.
That's okay.
Yeah, someone asked this question. I don't know how, people want to become multimillionaire. So is there a huge chance to be a multimillionaire? I'll drop it in the chat also. From a research, or it depends on the kind of research. Uh, can it come from
Yeah,
anywhere? I would say.
yeah. It's a great question. I will say in the tech transfer world I'm operating in right now, um, usually the big financial successes are coming from new drug discoveries, like new pharmaceuticals that are brought to market. So if you're working in that space, you have a lot of opportunity, let's say, in the traditional tech transfer process. I have worked with startups that have raised probably close to $100 million in funding that were launched
Uh,
by grad students. And those are in all kinds of sectors in new materials and chemistry and uh, actually a concrete company that was launched by two marine biologists is one of the more successful companies in agriculture. So I think if that's something that motivates you, launching a startup could be something to consider. But it's probably going to be very hard for the first 5 years, and not everyone makes it. So
Yeah, I agree. Not everyone is gonna make it. So if you would give it on a scale of 1 to 10, regardless of the research, say everything is uh, every of this idea makes sense. People, say, love this idea. From your experience, how many of these ideas have really like make made it to like multi-million venture?
yeah,
Directly translating their research on a scale of 1 to 10, how many were able to make it and become multi-million dollar
yeah.
venture and they are still in existence?
Yep, I just Googled it because this is a stat that I often like to have on hand, but it looks like the number now is 75% of venture funded backed companies fail, and a larger number is 90% of new businesses fail.
Mm,
Um,
mm,
so
fair.
so
Expected.
yeah, so it's a high number. Um, but I think there's more to be considered than, failure is a way that you learn. I launched a startup out of undergrad and it failed, but it propelled me into working in kind of the open innovation space. I got to live and travel around the world. I now own a small business with my wife, right? Like I think there's a lot of failure is only failure if you fail to learn from it.
That's true.
So,
Yep.
yeah,
Yeah. You can feel free to drop your questions. We can take one or two more questions in the chat. And then I'll get those questions. I can see David. I think David wanna translate his, file, his chemistry stuff into. But David, you need to ask a question. Yeah.
Uh,
Okay. Well, I have one more question here. Maybe I can ask one final question from my end as
absolutely.
well.
Yeah,
So beyond the gap fund, what
Mhm.
else do like Penn State like help researchers with, aside from the legal, handling the whole legal process, the transfer process, documentation, patent, and the likes? What other like financial benefit do
Yeah.
researchers get from Penn State
Yeah,
aside
yeah,
from
yeah.
the gap fund?
So the Gap Fund is a great mechanism our office runs. I would say a lot of people that come through our office get college level seed funds.
Hmm,
I think the seed funding program that exists at a lot of colleges is really a fantastic mechanism to get some early research funding. Um, on the entrepreneurial space, I'm going to drop in a link here. So I'm not sure if you've been to the Happy Valley Launchbox, but it's in the Innovation Hub, which is located behind Cafe 210. So we're downtown, but we have a physical location where people can come work, but they also run quite a number of programs, some that provide funding, such as the Summer Founders Program. It provides a $15,000 grant for current students, both undergrad and graduate, to try to further their startup. There's some other kind of funding programs that are provided there. I think those are probably the ones I mentioned: Seed Fund, Gap Fund, and then the programs through the Invent Penn State programs. Um, Also, when I was a student, I was able to leverage a lot of these funding mechanisms at Penn State. I think we actually got about $50,000 in grant funding from a variety of sources that helped propel our startup and helped give me some runway, so that I could not take a real job and try to do my startup. Um, so it definitely is possible. And then once you start to get a little bit of traction, there's a lot of other opportunities out there that exist. There's external fellowships that provide $200,000 fellowship to entrepreneurial grad students. There's a lot of different pathways, but I think it's best to start with what we have here in the university.
I agree with you 100%.
Yep.
Thank you so much. Maybe one final question from my hand. And if there is any other question from the chat, you can also take that. Yeah. So aside from like coming to Penn State, the tech transfer team, they can help you with a lot of stuff. What are the very like other extra thing that this, researcher can do to network with like, funding agencies and the likes, like aside from like Penn State now? What are the networking opportunities? What should they consider? What organization, society should they like partner with, join,
Yeah.
to really move
I
very fast? Should they just go to Silicon Valley and
I would recommend, this is a good question. So I will say something I've seen that I think grad students need to improve upon is the present, I think grad students are prepared to deliver academic presentations and academic poster shows, which is not, that does not translate into industry or
doesn't
startup.
bring the money? Yeah.
Yeah. So I would recommend like Pittsburgh has a tech week. I think it's called Pittsburgh Tech Week. It's
Cool.
organized by Carnegie Mellon in
Mm-hmm.
September. Like go to the Pittsburgh Tech Week. Philadelphia has innovation days happening all the time. If you just search like the innovation day or events in Philadelphia, I'm sure you'll see something. Like I'd encourage people here to like if it's of interest, like go just to observe, see what's happening in some of these other places, and think about how you can apply that to your own work. Because it is different. I would be horrible at giving an academic presentation. So like they're different skills though, right?
Yeah, I agree. Yeah. I mean, that would be very important, having to be able to translate your technical stuff, modeling, mathematics, whatever, chemistry, into like something very like visually attractive, convert those into money. These financial guys they are not necessarily like interested in how you mix those chemicals together, but they are like interested in, what is the output, what can it give us, things like that. That's a very important thing. Yeah.
And and you guys have a leg up now. Use Copilot, use AI to help develop this, right? Like
Yeah.
we use it all the I shouldn't say we, but I definitely use it to help understand some of the harder technical things, but then also to start to build a case
Mhm.
for like what is the I'm not an expert in the glass market with flying glass, but now I have abilities to use tools to start to figure that out. So
Yep. Because I'm on this call, I can also just show, okay, you can see my background. Just behind me where I'm sitting there is lab where line class was founded. Just next to my lab. Yeah.
that's awesome.
Uh
That's amazing.
okay, David has a question. David, why did you come late? Your chemicals, I don't know. Yeah, you can ask a question, David.
Hello, Jared. Thank you. Thank you, Debo. Thank you for the presentation. My question is, as international students, we we normally get stipends. So if we commercialize our research and money starts coming in, is it something that we can start getting while still in grad school, or is only when we finish our PhD program that we can commercialize it? I don't know if you know of any international student or anybody that has been able to do that. Thank you.
Yeah. Thanks, David, for the question. I have definitely worked with international founders. I do know that it depends on the visa that you're on, and I think that's about all I can say there. I would make sure that you double check with your attorney and the people at Penn State. I have I think anything is possible if you work hard to kind of navigate some of this. And I recognize that we're in a pretty tough time with immigration at the moment. So I don't have a good answer for that, but I think it is something you should be aware of if you're considering this path. So yeah.
Just so like David, yeah, I think maybe there is a potential like because we know Penn State have like legal backing and then we've seen that they support you with it like any legal even as a grad student, regardless of whether you're international or native or whatever. Yeah, maybe like seeking legal advice from that department itself, which might not necessarily be from your office. That might be helpful. Yeah.
We do not want to let Jared go. Like it's so
I'm
obvious at
done.
this
I'm done.
point. I've enjoyed this conversation. I've learned a lot of things, and I'm sure other people have as well. You can drop your reactions. I've learned a lot. Thank you, Jared. You literally left no stone unturned. I would even say would like to invite you another time because I've thoroughly enjoyed this session. Thank you so much for honoring our invitation and doing a great job at it. We really appreciate it. And I also want to thank everyone that honored this invitation and showed up today. Thank you so much for joining us. Jared, would you be willing to share your slides with me personally so I can send like to people?
Yep.
Is that something
Yep.
you're open
Happy
to?
to.
Oh,
Yep.
great.
Yep. I will share them with you afterwards, and then I just dropped
Okay,
my email in the
great,
chat. I'm
great,
happy
great.
to
Thank you. So
try to
we'll
set up a
share the
time to.
slides, we'll share the recording of this session, via email. Thank you so much, everyone. And our time is up. It's been a great time. If we have updates for you, we're gonna drop it on Springboard SC on LinkedIn. Do well to follow us if you've not done that already, so you can get updated. And that will be all for today. See you next time, everyone. Bye.
Bye bye. Let me go myself.